Let's now talk about case number 2, where the equals method in a particular class is explicitly overridden to a new version, which means the default version that's inherited from the object class is no longer applicable. That's the overall picture we're going to illustrate in this current video. Let's, before we do the example, also the point class, let's now talk about some principles of designing your equals method. That's something you can keep in mind to also double check to see if your equals method is really designed in a consistent way. Okay, so let's say we got reference variables x and y, x, y, z, and they are not null. Okay, they simply they store references of some objects in the memory, so they are not null. The first property is you want to make sure if you try to say x dot equals null. So remember, x itself is not null. So if you say x dot equals, you are trying to invoke a method, there will not be any null pointer exception for sure. And if you're trying to compare is x, which is not null, equal to null, apparently the result is going to be false. So the symbol over here, for those of you who might be taking a logic course, like a logic in computer science course. So this symbol here means logical negation, meaning that whenever you try to say x dot equals null, it should always give you false, which means the negation of false will be true, which is a theorem. Okay, that's what it really means. Okay, the second one is about reflexivity of the equals method. If you simply say x dot equals itself, it should always be a theorem. It should be always true. And if you also symmetric, if you say x dot equals y is a theorem, if and only if y dot equals x is also a theorem, right? That also makes sense. If I can say if by using my customized equals, I can conclude that x is equal to y. Using the same customized version of the equals method, y should be equal to x as well. So here, the only difference is we are swapping the order between the context objects and the arguments. It should not really impact the result if you're using the same customized version of the equals method. Okay, the last one is about transitive, right? Actually, we have seen this in your elementary school. If you say x is larger than y and y is larger than z, what can you conclude? X is larger than z, similar. So if I say x and y are equal, y and z are equal, what does that mean? That means x and z, they should be equal as well, assuming that we're using the same version of the customized version of the equals method. Okay, so these principles actually come from the official API for the equals method in the object class. I'm including the reference over here. Click on that, you can take a look as well. Okay, so these are the principles you want to keep in mind about designing the equals method. Let's now talk about version number 2. The rationale of having this version number 2 is because we want to compare contents of the two objects rather than their addresses. So that means we got to override the equals method. That's why we got version number 2. Let's clarify that first. And in Java, if you want to customize the equals method for your class, there is a more standard way of doing things, which will occupy parts of your methods. I'm going to explain that, and then there will be some part that will be up to your customization. So we're going to explain both parts carefully. Okay. Let's say we have the point v2 class over here. It's a version 2, v2 over here. And we still have the two attributes x and y. So we want to make sure when we compare two point v2 objects, we don't want to just compare their references. We want to make sure they are equal as long as their x and y coordinates or their location on the 2D plane is actually equal, right? In the same location, I meant. I'm going to go over line by line. We actually got several lines over here to explain. So let me now go line by line and explain them one by one. Okay. The first one, we say that if this equals obj. So what does that mean? Okay. So that means the context objects over here is the same as obj. Does this look familiar to you? This is actually the definition that we explain. That's in the default version in the object class, the equals method, right? So let's now take a look. Number one, let me just clarify that. You can see every class, including point v2, will inherit from the object class, meaning that this is the parent or superclass, and this is a subclass or child class, right? Because we chose in this case to explicitly overwrite or redefine the equals method, which is exactly here, right? You can think about this part over here is, you know what? Let me use a highlighter just to, okay. So you can see this part over here is the overridden version of the equals method, right? It's really important to first of all see that. Okay, so this is the overridden version. So that means the default version from the object class is no longer available. We don't invoke that anymore, like in version number 1. No longer available. Okay, it's really important for you to notice this point over here. No longer available. Okay, and let's now explain line by line, right? The first line that we just saw was this one here. Let's see the first line here. We say if this equals obj. So this kind of corresponds to the default version over here. So you can think about in some way we are still adapting what's really specifying the default version, but when we are overriding it, we're extending something else on top of that, right? So the first if then else is really corresponding to what we would do in the default version. Okay, so this one we already explained. This one is rather straightforward, just the context objects. If it points to the same objects as the argument obj, right? You can see obj is the argument over here. In that case, if they simply point to the same objects, then they should be equal. So that should be returned true. The first one should be easy, right? But we'll see some example in a moment. Okay, the first one is good. And another thing I want to notice, okay? You might be wondering, Jackie, you told me that whenever you want to implement a method, you better have a single return rather than multiple returns. Yes, I said that. However, given that this way of implementing the equals method is very standard among Java programmers, so I'll rather maybe show you that standard way of doing things. If you are interested, you can feel free to really convert this version over here into a single return version, which to me, I think to my judgment is actually a better way to understand how the logic should go. Okay, but I'll put on the as an exercise for you. So a little exercise for you. Okay, so you can convert it to a single return version. Okay, so I'll leave that as an exercise for you. All right, let's now take a look at the second line for the equals method. Oh, over here. Let me just go back to the slides. So this will return true. What about the second line? Second line is saying this. If the argument objects equals null. What does that mean? That means we're comparing the context objects versus the arguments, and the argument object is actually null. In that case, we'll simply return false. Okay. This one here, there will be some later exercise which I'll discuss a little bit further about this branch specifically. But for now, let me just make some notes for you. So let's say this. Let me use the blue. If obj equals null, in that case, we're going to return false, right? So you might be wondering, what if I say objects is equal to null? So that means this particular argument is simply null. For example, I might say P1 dot equals null, right? What if I try to call this, right? Should it evaluate to true or false, right? In this case, P1 is really pointing to something that's not null, and you're comparing that with null. Apparently, they should not be counted equal, so that should be false. This is okay. Let me pose one question to you, and which we'll revisit in a moment. What if P1 is also null? Should we return true instead? Because null and null are actually considered the same, right? So here is my question for you. Okay, it's really important. What if P1 is also null? In which case, we are really comparing null dot equals null. Should we return true instead? And for those of you who might be careful about listening to my intention, you might know the answer already. But if you don't know, that's okay. I will rather you get a little bit puzzled by this question here for a little bit longer. But I will revisit this in a later part of the module to do the exercise for you. Okay, I'll leave that just up to here. But for this particular branch over here, if object is simply equal to null, in that case, just think about, I can tell you that normally you will only run into this case for P1, which is pointing to not null. So if you're comparing something that's not null with something that's actually null. Okay, so something that is not null, which is the context object this, with null. So that means they are not equal. So that should be returning false. Okay, so that's about the second line. All right. And as I promised, I'll revisit this exercise a little bit later. I'll let you think a little bit more about it.